Today's lecture we're going to be talking about polymorphism. So polymorphism is a concept in object-oriented development that we've actually been using all along. And what it really means is that you can assign a derived class object to a base class reference. So what does that really mean? Well, if you remember our previous examples that we've done through the class, we had one where we actually created some vehicles. So if you remember this class over here, this class vehicle, and we had various things in it like model, make, and color. Well, what we could actually do is if we have this vehicle class, so let's do this. So this was the name of the class, and let's say we created a vehicle reference to it. Now we haven't actually instantiated the object. This is just an object reference to the vehicle class. Now what we could do is we can take this vehicle object reference and we could actually put a car object inside of it. So this is the base class. Car is the derived class from CLS vehicle, and so when we instantiate a car object, we can assign that object its reference into this object reference. Now why can we do that? Because vehicle is the base class. So an object of a derived class can be treated as an object of its base class, but the reverse is not true. And this is, we also learned a little bit about this before with that is a relationship. So if we had, like, let's say we instantiated a car here, I'll call it clsMyCar equals a new car. Now when we do this, we could have an if statement that said something like if my car is a vehicle, then we could do something. And so that's where this is keyword comes in handy, where we can actually then test an object. And if you remember from other examples like tic-tac-toe, where we had lots of different methods, or sorry, lots of different objects that were all calling the same click method. Well, in that click method, there's a sender object that we could use the is keyword to see if that sender object that got passed in was a label or a button, things like that. So that's kind of the basic of idea of polymorphism. So now let's think through some examples here of how you'd actually use this in the real world. And I want to go through a video game example. And so one of the things about a video game, the way it works, is that as they're creating the game, they first think of all the different objects that are going to be in the game. So let's come up with some objects, some classes that are going to be used in our video game. So something like, maybe a laser beam, maybe like an alien or a planet. So maybe there's a spaceship. So there's all these different objects that we're going to have to code. And each of these objects are going to have all kinds of different attributes and methods inside of them. And they're going to be all very unique to those given classes. Now what would be nice, in a lot of games you have generally like one method that sort of loops over and over again. And every iteration of a loop you want to then draw. So you do a bunch of computations on where the spaceship should be, where the planet should be, where the alien should be. Maybe someone's shot a gun and there's a laser beam. So you do all those calculations, and then now you need to then update the user interface, or the game itself, and draw where each of these items should be. So what would be nice is that if we could create like a large space object array. So we could have this whole array. If we could just fill up this array with lots of different types of objects, and then all of them call a single draw method, that would be really helpful, because that's no matter what type of object we want to draw it to the user. So how can we set this up? Well, what we can actually do is we can create a base class called space object. Now what we would then do is we would inherit all these derived classes from the base class space object. Now what we would do is we would create a draw method that would be overridden by all these derived classes. So what that would allow us to do now is we could actually instantiate an array of space object. We can instantiate lots of different laser beams, lots of different aliens, fill up this space object array. Then we could do a for statement, loop through this, and each time through the iteration we could call the draw method. Now here is where the polymorphism takes over, that each of these objects, remember this is a space object array, so it would look something like this. So it would be, we're actually creating an array of space objects. Space object equals a new space object array, 4 elements, whatever. It could be 1,000 elements. And then what we would do is we would loop through this array here, and we'd then say so.draw. So space object.draw. Now it is saying space object.draw, not laserbeam.draw, not alien.draw. But because we have these derived classes inside this base class and polymorphism, the draw method that gets called is actually the laser beam draw method, the alien draw method, the planet draw method. And they can do that because they all inherit from the base class, which defines this draw method. And we can override it in all the base classes. So I want to just read a sentence from the book now that describes polymorphism, and we'll see if it makes a little sense to you now. Let me just put it in here, probably make it easier. 1 second. Okay. So C# determines which version of a method to call from the type of the object on which the method is called, not the type of the reference that refers to the object. Now, it's a confusing sentence, but it actually does convey what we're trying to get across here. So let's walk through it. C# determines which version of a method to call. Okay, so that's this draw method. So when I say so.draw, which version of the method should it call? Should it call spaceObject.draw or should it call laserbeam.draw? So let's finish the sentence here. Version of the method to call from the type of the object on which the method is called, not the type of the reference that refers to the object. So this is the reference here. So the space object is the reference. It's not the type of object that's contained within that reference. So again, let's go back to that click event that we talked about before. If you're passing in buttons and labels into the sender object, you can do that because they're both the object-based class, and then that sender object now has like a toString method. Why? Because they're all the base class and they can call toString. And now hopefully this outer space example kind of gives you a real-world example where this kind of stuff is actually used in games and things like that. So next I want to talk to you about what are called abstract classes. Now, abstract classes are essentially this space object up here. And what we do with that, let me just comment this out so it doesn't create us more problems. So what we could do is, let's do a different example. Let's say public abstract class shape. So this also could have been something like this for our example up here, space object. But let's kind of move on to another example here. So what does this abstract keyword mean for this shape class? Well, if you never intend to actually instantiate this shape class, but you do want to allow users to derive from this class, and those objects you would instantiate, that's where you use this abstract base class. So here, it would never make sense to actually say space object equals a new space object up here. That's not the point of the space object. The space object was to create this sort of common base class that all have a draw method in it. But you'd never actually say space object equals a new space object. Just like you wouldn't say shape equals a new shape. I don't know what that means. So let's say we create kind of the same concept here. Let's say we say void draw. So now we're also going to use the abstract keyword here. So an abstract based class means you can't instantiate the class. The purpose is then to define methods such as this one. Now you can actually create regular methods in here also, but I just wanted to get the point across of where the differences lie. And here you create this abstract method draw, and this forces any derived classes to implement and create the draw method. So if I were to create another class called, let's see, circle, and we want to inherit from shape, whoops, one too many. I think it's not happy with where I'm doing this at. But anyway, so we have our circle class, and we're going to inherit from shape, and you'll notice what it's telling me here. Circle does not implement inherited abstract member shape.draw. Well, the compiler is telling me, hey, you told me you're inheriting from shape and it has an abstract method in it, therefore you have to have that method in it. See how that guarantees you that every derived class has this draw method? Well, that's going to be the same as we talked about up here. So if the space object has this draw method in it, that means all of these derived classes also have to define the draw method. And that's how you can guarantee that so.draw will work. So down here now, there's a few ways you can do this. You can either just implement it yourself, or you can actually click the little here and say implement this, and then it actually puts that method in there for you automatically. So that's kind of nice that it actually, you'll see it overriding this abstract draw method. And so we'd have the circle, triangle, square that implement this draw method. And so if we created an array or list of this class shape, we could say dot draw and loop through that array, and it would draw a circle or a square, etc., etc. So some rules of this, these abstract methods, they can only be contained in abstract classes. They do not provide an implementation, so you're just providing that signature. Now, it's implicitly virtual. So if you remember in the previous lecture, we talked about the virtual keyword, which allowed you to override a base class method. Well, by default, this is virtual because that's the whole point of this method here. So now let's talk about another example that we've been using all along, back to that employee like payroll system. And so this is actually starting to be a better example now of, I think, how you would use this in the real world. So in the real world, you'd have all kinds of different employees in your business. So again, imagine that a small company came to you and they wanted you to create some kind of employee payroll application. I mean, I've done consulting jobs just like this, where I've created invoice systems for small companies. And so this would be a great way to start setting up the program. And again, you really have to think through all of the information of, hey, what type of employees? And in this particular job, they have salaried employees, they have hourly employees, they have commission employees, base plus commission employees. And so you're looking, you start noticing all these types of employees, and you think to yourself, what commonality do all of these employees have? And we can create an abstract class employee. Now we're creating it abstract because it would never make sense to say employee equals a new employee. We don't have just employees. We have salaried employees, hourly employees, etc., etc. So it would never make sense to instantiate an employee object. Only these specific types of employee objects. However, all of these types of employees have this same exact information. Now remember, this is a simple example of an employee that only has 3 attributes, right? But they could have 1,000 attributes. It doesn't really matter. If they're all common to these right here, you put them in a base class, and that way you can reuse that code. One person can create this class here, this base class. Then you have other individuals, other programmers that can use these classes for whatever job they have to do. You'll notice I've got my employee constructor here. I've got my toString method. Now here's an abstract method here. So what this says is that any class that inherits from employee must have an earnings method in it. So what does that mean? So they're basically saying, hey, an employee is going to earn some money. However, I don't know what that means because as an employee, it's very generic. But if I'm a salaried employee, earnings means I have a yearly salary. So I make $50,000 a year, $100,000 a year, whatever my salary is. If I'm an hourly employee, then it depends on how much my hourly rate is times my hours. Commission employee, how many sales I make, plus my commission. And so the derived classes will then implement this earnings interface. So let's take a look at that. So if we come over here to our salaried employee, you can see that it inherits from our abstract class employee that we just looked at here. Again, remember, it's abstract. And so with that, we then fill in the extra details that are specific to our salaried employee, all of this stuff. So we create the constructor, we create some properties, and then here's our override for our earnings. Now, this is a little bit different syntax that we haven't really talked about. It's what's called a lambda expression. It's exactly the same as just doing this. That's all it is. It's just a different way to write a method. I personally don't like it. I don't like the syntax. There's other areas where it makes sense, but for me, I don't like this shorthand. It's a little more confusing to look at. it's a preference, but that's kind of the way I am. So if you see the examples like this in the book, that's all it really is. You can just literally replace it like that, do a return, and then if that's easier to read for you. It is for me. So that's kind of the way I do things. So now we've got our salaried employee, and the only thing we really care about, so they put all these specific properties, is that we're forced to implement this earnings. And you'll notice we just return this weekly salary. So that's what a salaried employee gets. They return weekly salary. Now, if I were to come in here and cut this out, then we'd actually get a compile error because we've not implemented that employee earnings method. Now someone else can code what it means to be an hourly employee, but they're getting all of this code from the employee class for free. And then we come down here and we know which method that they have to implement. They're forced to implement this earnings. And so again, there's a specific type of formula that an hourly employee is going to use. And then a commission employee is going to do the same thing. So this earnings here. Now at the end, what this allows us to do, so now this is our main method where we're actually going to do this. So here we're creating a salaried employee, an hourly employee, a commission employee, and a base plus commission employee. So these are all different types of object. And remember, the var keyword does not mean variant. It means that it's just a variable that allows you, so it's strongly typed. So if I highlight this, you can see it's hourly employee. So it's exactly the same as just putting hourly employee here or salaried employee. Again, I generally don't use the var keyword for this type of purposes. Generally just for a concept called link that we'll talk about in a later lecture. So now what we can do is here we can use the individual methods called earnings. So this isn't anything new here, right? This is just methods implemented by each one of these. So it's just showing you that each of these objects have an earnings method. And that's pretty straightforward. However, this is where the polymorphism comes in. Notice how they're creating a list of employee objects. Now again, employee is our base abstract base class. So even though we're using the new keyword, we're creating a new list. We're not creating a new employee object. So there's a difference there. So we're creating a new list of employees. Then what we're doing is, this is just the same thing as saying .add. And so you'll notice to our list, we're saying add our salaried employee, our hourly employee, commission, blah, blah, blah. And so notice we're adding objects of different types to our list of employees. And we're able to do that because they all derive from our abstract base class. So you could not put a different type of object in here that was not derived from your object base class, or for employee base class. So now what this allows us to do, going back to that video game example that we just talked about, we can do a for each statement. And notice what we're doing here though. We're saying for each employee, get that object in employees. Now employees is a list of employee object. Okay, so now what we need to look at here is what happens if I say current employee dot. Notice what pops up here. The only thing that pops up from the compiler are methods that are guaranteed to be in that abstract base class. And so you'll notice things like earnings, first name, last name, social security number are there. It doesn't know about any of the derived class attributes or methods. The only one it knows about is earnings, and that's because the base class created this as an abstract method. So we're guaranteed that every class derived from class employee will have an earnings method. So what we can do now is we can first say, okay, let's take a look at this employee. Maybe we want to do something special if it's a base plus commission employee, but only if it's a base plus commission employee. So we can use that is keyword and we'll say, hey, if this current employee is a base plus commission. Now you'll notice that for the first three items, none of them are base plus commission objects. So for the first three loops, this if statement's just going to get skipped over. Then it's finally going to hit this base plus commission employee object. That loop's going to go true. Now here's where they're saying, okay, we're taking this base class object reference and we're casting it to a base plus commission employee. Now this is a safe statement to make because we were told that it is this. Now why did we have to do this? Because now our employee object is actually, we've cast it to an actual base plus commission employee. So now if I do this dot, we get all of the methods associated with a base plus commission employee, not just the abstract base class. So we had to then cast it back to our more specific derived class in order to get those methods. Now the next thing with polymorphism, here's this current employee. So again, remember this is just this object that we're looping through in our for loop. Here's where we call that earnings method. Now again, this is an object-based class of type employee, and because it's abstract with that one method in it, it can call the earnings method. And so if I were to right click on this and do go to definition, you'll notice it's going to my base class definition, but that was abstract, so it actually calls the earnings method within the type of object that is contained within this list that this current employee object is created from. So hopefully that's just clear as mud. As you use this a few times, it'll start to sink in and make more and more sense. So with that, I want to talk about just a few things in general. So you also may see like a sealed keyword, and that just means it's kind of like the opposite of abstract, and it's just saying, hey, you cannot inherit from this class. So there are going to be times where you're just saying to yourself, this doesn't ever make sense for someone to inherit from my class, and I don't want to let them. Same way you could use what's called a sealed method, that you can't override this particular method from a derived class. So if you override a method, like toString or earnings in one of these derived classes, you could then declare it as sealed, and then the next class that derives from your class couldn't override it anymore. So the next concept I want to talk about is what are called interfaces. So interfaces can be a little bit confusing, but they're related to polymorphism. And what it really does is it's a way of kind of bringing objects together that you wouldn't normally think are related. So it doesn't make sense to inherit these two objects from the same base class, but they're still kind of related. And we could actually go ahead and go back to that space game example. So if we came back over to here, another way that we could have done this is instead of created an abstract base class, we could have created this space object. We could have called it, a space interface instead. And that space interface, rather than an abstract class, so we use the interface keyword. We'll look at the syntax in just a second. But notice how maybe it doesn't make sense to have all these actually derived from here. Maybe it makes sense to call this a space interface, because laser beams and aliens and planets and spaceships don't actually have anything in common other than they're sort of objects in our game. So what we could do is we could define what's called an interface, and then that interface works just like inheritance, but what it does is you sign a contract with a compiler that says, I will implement this method. So just like in our abstract method here of draw, we could have this draw inside of an interface that would bring these classes together. So let's take a look at an example from our book and see if this makes a little bit more sense. So remember, our abstract base class over here for employee, it's good for providing data and services that are related, where an interface is more to bring objects together that aren't related, that probably don't make sense to be inherited from each other, but we need to bring them together. And we use that with the interface keyword. So for example, in this particular example from our book, I'm first going to start with the actual end code. I'm kind of doing things a little bit different because I want to show you what the expectation is at the end to be able to do. So in this example, we want to be able to create invoices and salaried employees. So in that previous example, we had types employees, right? But they're not really related to invoices. But we want to be able to get a payment amount from both of these objects. So an invoice and a salaried employee should not have some sort of base class that they both derived from. They're not really related in that sense. But they are in the idea that they're both payable. An invoice is payable and a salaried employee is payable. So what we can do now is we can create an interface called iPayable, kind of just like we did with those abstract base classes, but an interface doesn't provide any implementation, but it forces you that if you inherit essentially this interface, that it guarantees you that it'll have whatever methods in your interface you defined, kind of like that draw method. So what we can do is we can create a list of our iPayables, fill it up with objects of invoice and salaried employee that have implemented the iPayable interface. And then in our for each loop, we can actually then use polymorphism just like we did before. And you can see that payable is of type iPayable interface, but we can still say get payment amount because both of these types of objects implement the interface iPayable, which has a get payment amount. So again, this is the end product that I wanted to show you what we're trying to do. So now let's actually look at this iPayable, and we'll come right back to this part. So notice here, here's our public interface called iPayable. So we're just saying to ourselves, okay, I've got these objects of different types. I know that both of them, I need to be able to get a payment from them both. Therefore, I'm going to create this interface, and you'll notice that there's no implementation here. It's just the return type and then the method name. So if I come back over here, you can see that's where this get payment amount comes in. So let's take a look at the invoice. Now it looks just like inheritance, but what we're saying is we're implementing this interface. So we're signing a contract with a compiler that says, I guarantee you that I will have a get payment amount for my invoice. So this invoice is now defined what it means to get a payment amount. Now we're going to do the same thing for our employee class. So here's that original employee class, and now we implement iPayable. So what does that mean? Well, it just means that we're going to implement the iPayable interface, and that means we define the get payment amount method. And we can do the same thing for salaried employee because it implements the employee interface, or sorry, the employee base class. So it by default has to have that method because employee implements iPayable. So you can see how the different layers can actually be sort of derived here. And we've seen something like this before. If you remember when we clicked on like a button and then I kept doing go to definition, the base class definition, and it would go to like the control and then UI control, and it would go all the way up the UI visual interface. And then there was multiple items out here. Well, that's what it's doing, is that it's looking up that chain. And so let's take a look at that. So if I were to come over here, actually we can do it in the code. And let's just create a button real fast. Doesn't matter, but if I go to button, I right click, do go to definition. So you notice button inherits from its base class called base button. So you can see it's a class. So if I do go to definition, the next one up, oh, here we go. Now remember, C# cannot have derived from multiple parents. So here's our class. Here's the class it's inheriting from. But oh, by the way, it's also implementing this interface. Now I know we don't know exactly what these interfaces do and things like that, but we can at least read the code and then understand what's going on. So notice here I command source. So if I right click on this, I know that there's going to be some things defined in here that this class has to implement. So if I right click on here, go to definition, sure enough, here's some things that it actually does implement, like command target or object represents user-defined data type that can be passed to it. So I know that this property has to exist back on that method or back on that other object. And so that's a way that you can sort of bring objects together and have this idea of the multiple parents, but really you're just defining an interface here. So let's see. So let's go back to that space game real fast. And so hopefully now that if we go back to this game, again, we would actually create this as an interface here. Our space object would have this draw method in it. And so what we could do is now this would still be true up here. So now each of our game objects here, laser beam, alien planet, would all implement this interface. And now they're all guaranteed to have this draw method. So another way that you could abstract out the code and implement it. All right, so now let's take a look at operator overloading. So it's rare that I use operator overloading, but I at least want you to understand the concept if you ever do need to use it. And it's just the idea. Let's take a look at the end example over here. Is that you'll notice that we're instantiating a complex number called X and a complex number called Y. So we've got two objects here of type complex number. And again, this could be vehicle or whatever, shape or, laser beam, whatever object. We're calling it complex number. So we're going to do some, actual math with it. And so what does it mean to say X plus Y? And you'll notice that that's what they're doing right here, or X minus Y. And remember, these are two objects. I mean, what would it mean to say vehicle plus a vehicle, or laser beam plus a laser beam? So you can define that. And so what that means is you can overload this plus operator so the plus operator knows what to do with our specific types of objects. So it knows what to do with integers, so it knows what to do with 3 and 2, but it doesn't know what to do with two complex numbers. So over here, we've got this complex number, and if we come down here, you can see that this is the syntax if you want to do operator overloading. You just sort of have to memorize it. The method has to be static. Now it has to return an object of the same type of the class here. In our example, we're going to overload the plus operator. Now a plus operator takes two operands, the left and the right operand. So here we go. That's what these two represent. And again, it just does that for you. So this is the left operand and the right operand. And then this code could be anything you want in the world. They're just doing what it means to add two imaginary numbers together, these complex numbers. Or sorry, the real and imaginary parts. And so that's how it works. Now we're doing the same thing for the minus and the same thing for multiplication. And so what that allows you to do is it just makes this code a little bit more readable rather than, again, pretend this could take up 50 lines of code, right? So if it always means the same thing to add two objects together and it takes you 50 lines of code, you can now reduce all of that to just one symbol or one operator. So that's one way that you can do it. So now let's finish off the lecture going back to our original example of our class vehicle. So here's our abstract class vehicle. So the only thing that I changed here was I made this abstract. So what that means is in our actual program we can't instantiate any objects of class vehicle. Now it wouldn't make sense. Think about that in the real world. What does that mean to create a vehicle? Well, it's an abstract concept. It doesn't make sense. What does make sense is to create a truck or to create a car. And so those would be the derived classes of our class vehicle. So nowhere in our code can we say, CLS vehicle, my vehicle equals a new vehicle. Down in my methods here, I've created this abstract method called abstract method example. So by doing this, I'm forcing any derived classes to create this abstract method example method in it. So if we go over to, let's say, a new truck class, it's going to inherit everything from vehicle, but it's going to force me to implement this method. So again, if I were to get rid of it, it's going to give me a compile error because I did not implement this abstract method example. Now I override this method and I make it specific to whatever means to have a truck, this specific to a truck, this method. Now I would do the same thing if I were to create a car and inherit from this abstract class vehicle. And then again, I have to implement that abstract method, but do it specific for a car. Now if we come over to our main here, you'll notice I had to comment out all of these lines of code because, see what's happening here? I'm trying to instantiate an abstract base class, and it tells me cannot create an instance of an abstract class. And so that's why all of this has to be commented out in order for this code down here to work. Now we've got this other just button click. Now I'm creating an array here of type vehicle. So this is essentially that space object class. And now once I do that, I can instantiate some objects of some derived vehicles. So here's my car, my truck, and another car. Now because they're derived from the base class vehicle, I can add them into this array here. Then as I loop through this array, I can call that abstract method, and it's going to call the abstract method in the car or truck class based on which object type is as it loops through this object array here. So that's polymorphism. Again, as you start using it more, and I would recommend adding some labels and some buttons all to a click event, and then using the is keyword and just kind of writing the code yourself, I think it'll start to sink in. Thank you.